Hi, everybody. Thank you so much for coming to my talk when you could be out in the sunshine. I really appreciate it. My name is Jo Franchetti, and I am a developer advocate at Spotify. You can get me at This Is Jo Frank on most of the socials, whatever socials it is that we're using these days. And today I'd like to talk to you about the importance of developer experience and how we can improve our developer experience. But to start, let's start with a story to sort of illustrate what I mean by developer experience. So you're a software developer and you've been asked to integrate with a new developer tool. Let's call this tool codemagig. And someone at your work has told you that codemagig has been recommended for its advanced features and its time-saving capabilities. And you're excited about the potential that codemagig can offer, so you embark upon the journey of onboarding with codemagig. And you start with the obvious things, so you use your favorite search engine to find online tutorials, to find the documentation, and to try and understand the basic concepts of the functionalities of codemagig. However, you quickly start to realize that the available online learning resources are quite scarce, and when you do find them, they're poorly structured, and the official documentation is incomplete and it's out of date. It lacks clear examples, and it doesn't contain practical use cases. And you do end up finding some tutorials, but they're either overly simplified or they're overly complex, and you end up feeling confused and frustrated. So you're determined to overcome this initial setback, so you reach out to the codemagig community for assistance. You join their online forum, you join their Discord, just in the hope that you can get guidance from somebody, from an experienced user. But unfortunately, the community turns out to be unresponsive and a little bit hostile to newcomers, and so your questions go unanswered for weeks. But you're a consummate professional, so you decide you don't need documentation, you don't need a community, you can work this out on your own. So you're going to experiment with codemagig by working on a small project. However, you quickly discover that the tool has quite a steep learning curve. The code base is complex, it lacks structure, and this makes it challenging to navigate through the features of the tool. Codemagig lacks proper error handling, it doesn't have great test coverage, and you get these sort of cryptic error messages that don't really help you with troubleshooting. And you find a bunch of bugs and inconsistencies while you're practicing with this tool, which you do report to codemagig, but they never actually respond to your reports. And as weeks turn into months, your enthusiasm for learning codemagig starts to wane, and you begin to question your team's decision to use codemagig. There isn't enough learning resources, the community is unhelpful, the tool has inherent flaws, and it's just a demoralizing experience. And you realize that the promising features of codemagig do not make up for its poor developer experience. Ultimately, you and your team decide to abandon codemagig for a completely different tool that has better documentation, has a supportive community, and a shallower learning curve. Bye-bye codemagig, you lost this customer because of your bad developer experience. And I'm sure a lot of you have had that exact user-developer journey. You've had that similar onboarding experience with tools. And this first experience when you're using a new tool or a language is absolutely essential to developers to help them decide whether or not they want to continue to use your products. It's going to sway developers to perceive the entire quality of your code within your organization. And developer experience, or DX as it's often called, or DevX, describes the journey that a developer takes when they're onboarding with your code, as they learn to work with your tools, and basically as they learn to work with you and the way that you're coding. It's the lived experience of developers and the points of friction that they encounter as they go about their everyday work. And developer experience isn't just in the getting started phase, it's all the way through. So we're talking building, testing, debugging, and releasing products using code that you have written. And as tech people who are building tools, even if we do manage to onboard people and we get developers to start using our products, to start using our libraries, a pleasant developer experience is absolutely essential to keep them in the future. They're going to leave if they don't have a good experience. They will find something better, they will abandon your project. Poor developer experience will cost you money, it will ruin your customer base and damage your reputation. And a common misconception is that DevX is only affected by tools and the products themselves, but research shows that there's a huge human factor in developer experience. So things like having clear goals or feeling psychologically safe while you're developing with something can have a substantial impact on a developer's performance. So improving DevX not only increases a developer's productivity, but also their general satisfaction, how engaged they feel, and how capable you are of retaining them. So let's take a deeper dive into what makes up developer experience. There was a recently released white paper by the Association for Computing Machinery on developer productivity, which I've linked to down there, and I will share out the slides at the end. And it breaks developer experience up into 3 sections. So we have cognitive load, flow state, and feedback loops. And when we consider these all together, these factors describe the full range of friction types which are encountered by developers as we work. So let's take a brief look at each of these, and then I'll go into some practical examples of how we can improve each one. As I'm sure we're all aware, software development can be quite difficult. It's complex, it's complicated, there are new tools, new languages, new frameworks, there's so much stuff to be learning constantly. And reading and writing and learning code all contribute to a workload on your brain, which we call a cognitive load. And cognitive load refers to how much information a developer needs in order to process or complete a task. And not only that, it's all the other stuff that is also going on in their heads at the same time. And it refers to how much effort it takes for somebody to learn and to retain the knowledge once they've learned it. And psychologists often refer to something called working memory, which is how much capacity your brain has to hold information temporarily. And it works actually alarmingly similarly to the way that RAM in your computer works. So you have a certain amount of this fast access storage available, which you fill up as you're doing tasks. And when that capacity is full, you've reached your ability to continue doing tasks, you will have to stop doing a task in order to pick up a new task, or you will find that you start to make mistakes, you start to slow down, you start to drop things. And cognitive load typically increases for a developer if they're working on a complex or a difficult task, or if they're learning something that's entirely new to them. But it can also be increased by extraneous information that is happening at the same time that they're trying to learn. So things like multitasking will increase your cognitive load. Working in a noisy environment, or working somewhere where there's lots of visual noise, lots of things happening in your periphery. And things like poor documentation, too much or too little instruction, badly designed tasks can all affect your cognitive load. And to add to that, if you are feeling tired or anxious or bored, this can also decrease the amount of working memory that you have available, thus decreasing your ability to take on new tasks, to learn new things, decreasing your cognitive load capacity. And when cognitive load is high, developers will need to devote more time and more energy and more effort into completing a goal, and they're much more likely to make mistakes if they're working while their cognitive load is high. So to improve developer experience, teams and organizations should be aiming to reduce cognitive load as much as possible. So we want to find ways to eliminate unnecessary hurdles in the development process. We should be doing things like creating well-organized code bases, writing great documentation, making sure that we're setting out well-defined tasks for people with clear objectives, and reducing context switching as much as we possibly can. And dedicated developer experience teams should be looking to make nice, easy-to-use self-service tools which are going to help developers to streamline the steps that they need to make in order to onboard with your project. And of course, it's not only for those who are onboarding, it's also for those who are well established and are bug fixing. We want to be making the steps easier and simple to follow. The way that I like to think about it is, imagine your developer is a sprinter and they're running on a track. Every single time they get to a point where they have to task switch or they have too many things to do, it's like you've just slipped a little brick out onto the track in front of them and they're going to trip over. And getting back up again takes that little bit of extra energy, and then they're sort of slow and they have to start up before they can start sprinting again. So we want to be removing as many of those bricks as possible. Presenting information in different styles and methods can really help, and this makes information accessible to people who have different learning styles. So make sure if you're, for example, trying to onboard a developer, that you provide them not only a written explanation of how to use your code, but also maybe a video explanation or audio. Give them a walkthrough, but also give them a fully working demo for the people who prefer step-by-step or prefer to just dive in head first. Allow developers to use the tools that best aid their own cognition. When cognitive load is well managed, developers can find it much easier to be productive and efficient. And it allows for this thing that we call flow state to start happening. And I'm sure you've all heard and felt it yourselves, this idea of being in the zone, or occasionally when you're in the zone, suddenly your flow state is like interrupted because somebody asked you a question or you received an email. And this idea of being in the zone is what we call flow state. And flow state is a mental disposition in which a person becomes fully immersed in the activity that they're performing. And it's really enjoyable, like it's an energizing feeling to be in the zone. And it can help with creativity, innovation, motivation, and efficiency. And being in a flow state can actually make it easier to learn. Stuff actually goes in faster and stays. It can make us more productive, and it can even make things like repetitive tasks feel actually gratifying. And this feeling of enjoyment, of course, is going to lead our developers to perform better and to actually enjoy using our products. So it stands to reason that we want to create an environment where we can provide optimal conditions for flow state. So in order to do that, we need to make sure that when we're building things or we're trying to teach someone something, the challenge and the skill level are well matched. So tasks should prevent enough challenge that the person is interested and they want to learn, they're engaged, but they're not confused and they're not frustrated. Too much challenge can leave you feeling helpless or foolish, and on the other end of the spectrum, too little challenge can leave you feeling babied and belittled. I remember once my dad called me and he was like, "Oh, Joe, my computer is broken." And I was like, "Why don't you look up a fix?" And his response actually kind of floored me. He was like, "I know that if you look up a fix, you will be able to find a fix within 2 hours. You will be able to apply that fix, and then my computer will be fixed. Whereas if I try and look up a fix, I could spend 2 hours looking at the fix. I would have no idea what I was looking at. At the end of it, I may still have a broken computer." His skill level was not up to the challenge that he was experiencing. He found it frustrating, and he gave up before he even started, basically. And when we're building experiences for developers, we should consider their skill levels and be catering for them as we're writing. We want to create confidence in the developer that even if a task is unexpectedly complicated, they are going to be able to work through it and solve it and complete it. And getting this balance of challenge and skill level will allow the developer to feel like they're in control of the process and their progress. Clearly defining tasks and setting achievable goals can really help with this balance. And I'm sure we all know that completing a task, when you get to put that little tick in your to-do list, it gives you a sense of achievement, and it can motivate you to then pick up the next thing and get that next check. And it keeps you in a flow state. If you're getting through tasks and you're doing them, you want to keep learning, you want to keep in that flow state, and it reduces the chance of you getting bored and switching onto a different task. And conversely, things like interruptions and distractions are going to hinder your flow state. So if developers are struggling to find the information that they need in order to use your code base, then you may find that they just drift off and do something else entirely. If they're constantly being pinged or distracted in an office, or they have to toggle between too many pages in your documentation, it's every time they are distracted, it's like putting that brick out in front of the sprinter. We've just given them a place where they're going to trip up, and then it's going to take energy for them to get back up and running. And then switching between tasks, feeling lost, frustrated. These are not the only things, obviously, that can affect developers' sort of energy levels. Things like if they are thinking about what they want for lunch, or they're feeling anxious about a meeting that they have to have. These can all also decrease your cognitive load and make it more difficult to stay in the flow state. And cyclically, being pushed out of the flow state constantly can also increase that anxiety and that unpleasant feeling in the developer and make them just not want to bother. So I don't know if you've ever found yourself doing something like you're midway through reading documentation and you come across something that you don't know about, so you go to look it up, and then as you swap back, you've landed in your email, and then you're responding to an email, and then you notice the Slack, and then it's lunchtime. Because you don't want to face the mental hurdle that getting back to that difficult problem presents. And flow state absolutely depends on developers having the autonomy and the opportunity to work on things that they find fulfilling. They want to keep going, they want to keep completing those tasks. And the best way to find out whether or not you've got the balance right is to ask them, to get feedback. And this brings us nicely onto feedback loops. And it feels like a really obvious thing to say, but sustaining meaningful feedback loops between developer effort and developer impact is central to creating a good developer experience. How could we possibly know whether or not we're doing a good job without actually speaking to the developers who are using our products? So feedback allows us to spot mistakes, it allows us to learn and improve, but it also fosters a feeling of visibility and a recognition of performance. So if you're looking to improve your developer experience, you should be aiming to shorten your feedback loops as much as possible. It's absolutely imperative to make your feedback seem easy so that we don't block developers from telling us what they think. And of course, not only do you need to collect that feedback, but you need to also action it in a timely manner. Because developers are going to stop giving you feedback if they don't think you're actually doing anything with it. And it lets them know that you appreciate what they're telling you. In doing so will allow you to discover where developers are struggling, where you've accidentally placed those bricks in your experience, and where their cognitive load has become too much. And this will ultimately lead to you building better and more beloved products. And similarly, we should be looking to provide feedback to developers as they use our products. So we want to get feedback to them quickly as they work to let them know that they're doing the right thing, that they've learned the right thing, that they're using our tool in the correct way. So we should have good test coverage in our code bases that lets developers know how to fix mistakes, We should, of course, enable continuous integration so that they can run their tests while they're working and get the feedback as they go. And we can offer things like steps in a tutorial with a clear indication that the developer has succeeded and is continuing along a journey. And providing slow or no feedback can actually, again, lead to increased cognitive load and reduced flow state. And I mean, feedback could be an entire talk in itself. So if you're wanting to learn more, there again is a tiny link down there to an excellent article on developer effectiveness by Tim Cochran, who is the technical director of ThoughtWorks, and he talks about feedback loops and how to implement them and how to measure them. That's a really excellent article. And the eternal question that we get asked in DX is, how do I measure this? How do I know if I'm making a positive impact? And the answer, as it so often is it depends. DX encompasses so many different aspects that it's quite challenging to quantify, but these are some of the things that you can measure that might help you gain some insight. So firstly, as I've said, run feedback, conduct surveys if you can, and use them to understand your customer satisfaction, to understand their pain points, and gather suggestions on what you can improve. So there's tools like Net Promoter Score and CSAT, which is the customer satisfaction score. And these will tell you how your customers are feeling at the point at which they decide to use your product. And it will tell you whether or not they would recommend your product to somebody else. And you can use them to sort of gauge an overall satisfaction with the thing that you've built. Make sure you're also tracking internal team feelings. So regular check-ins with your internal developer teams will give you an idea of where they think improvements can be made. And as sad as it is to say, check employee turnover as well. Vital information can be gathered at exit interviews. This is where you find out what you're doing wrong, where your developer experience is going awry. We can use code quality metrics such as code review feedback. We can check our code complexity. We can look at our code coverage. We can look at the number of bugs that are reported, the number of issues that are on our repos. And we should be tracking these metrics over time to see whether the changes that we're making are increasing or decreasing, basically whether they're having the desired effect. And we can also be checking our documentation quality here, which I will go into in a bit more depth in a bit. But you want to evaluate the accessibility, have a look at your code comments, your API documentation, your development guidelines, anything where you are basically speaking to a developer who you don't have face-to-face with you. You will also need to regularly check that your documentation is up to date and perhaps trim out anything that is out of date or now incorrect. And we can use things like KPIs, burn down charts, completed story points, number of features delivered, that kind of thing to measure team productivity. And there's an excellent research paper by Kat Hicks and her team over at Pluralsight on measuring what she calls developer thriving, which is a different way of thinking about developer productivity. And I really highly recommend you check out that link there, which is a link to her talk at Lead Dev and also the paper that she released recently. We can do things like assess the effectiveness of communication within our teams, the effectiveness of communication within our communities. So how much are we having to respond to email? How often are people communicating on Slack or Discord? How much time is being spent there, and is it efficient? It can also be a good indication of burnout if you notice that your developers are responding to email at midnight or on Slack 24/7. A good measurement is also things like participation in training programs or certifications or skills development. You want to be allowing your teams to improve their own skills. We don't want their nose on the grindstone all the time. We want to be giving them the time to develop their own skills, to make sure that they have the tools that are necessary in order to complete their jobs. And then, of course, we have also the development cycle itself, and there are so many things that we could be measuring here. So how long does it take to go from initial idea to deployed thing? Shorter development cycles usually indicate a smoother and better development process. We could be measuring the time that it takes, that our developers are spend debugging rather versus building new features. We could track how frequently code changes are deployed to production. If we're deploying more frequently, that suggests that maybe we're being more efficient. Remember that developer experience is multifaceted, so you're going to have to consider a lot of different things, both quantitative and qualitative, in order to get a full understanding of the DX within your internal teams and your external teams. And regularly collecting and analyzing these metrics can help identify where you need to improve. And it's really important that you're making data-driven decisions rather than just guesswork about what it is that developers want to see. And the overarching goal of developer experience is to provide a smooth and efficient environment for developers to work. And we can split DX into two sort of obvious categories. So each one is going to have its own unique challenges and considerations. So on one hand, we have internal developer experience, so that's the developers who are working with us directly, and on the other hand, we have external. So these are the developers that we never get to see face-to-face, who are working with our code bases in their own companies. And obviously, it's going to be much easier for us to define the audience of our internal teams. Like, these are people that we know, that we work with. They're a known entity. And our external developer audience will require research and surveys. But you should be able to make some assumptions about who it is that you want to reach, what their skill set is, and then you can provide guidance and customization options for differing user segments depending on who you've decided your audience is. So that is a really brief introduction to DevX, but I'd like to give you some practical takeaways that I think will make a real difference to your developer experience and the developer experience of your products globally. And these are things that I've seen that I think will reduce cognitive load, and these are things that help me to stay in the zone while I'm working. So let's start with the basics. First of all, let's talk about our code bases. There are some standard hygiene practices that, I'm going to tell you these and you're going to be like, that's really obvious, Joe, but I've seen things. So I'm going to go over each one, and we're going to talk about them, and you can implement them, and maybe it will make an experience to your developer experience. So firstly, a good code base follows the default language convention of the language that you're working in at the time. If you're going to deviate from these standards, you are going to increase cognitive load for your developers because it's not what they're expecting, no matter how well-intentioned you think it is. Every change that you make to these standards is going to raise the barrier of entry for onboarding to your projects. Also remember, every tool and every dependency that you include with your projects is adding to that cognitive load again. You're just putting more little bricks out on the path for your sprinter. And you can reduce time spent onboarding by making use of things like dev containers or code spaces. These are lightweight packages that contain your application code along with its dependencies. So if we can't cut down on dependencies, we can at least make it easier for developers to use them, to install them. We can create a developer environment that has a very minimal setup. GitHub offers code spaces, which will actually allow you to run your containers in the browser, which is super awesome. VS Code has a containers extension, which allows you to use a container as your full-time developer environment. There are things that we can be doing to make the onboarding experience better for developers. And if you can't use a container, at the very least try and avoid global dependencies. This is going to ensure that your project can be easily reproduced by other developers, and it's going to help maintain the integrity and the stability of your projects across multiple different setups. For example, as a Windows user, I fall foul of this all the time because basically everyone else at my company is on a Mac. If external dependencies can't be avoided, then you can script them. So if you're writing a web project, in the script section of your package.json file, you can actually define custom scripts that can be executed with npm or with yarn, and they will run and install your global dependencies for you. But again, remember, these commands differ between operating systems, so think of us Windows users. Your README plays an absolutely crucial role in your repository. It's the initial point of contact for a developer with you as a human and as a developer. It's the developer's introduction to your code and to yourself as a writer of that code. And it helps your users to quickly understand what your project's about, whether or not they might want to use it, whether or not they should even be interested in it. And a well-crafted README enhances the accessibility and the usability of your product. Investing time in crafting a comprehensive README is just the best way that you can communicate the value of your project and foster engagement with your developer communities. So personally, when I look at a README, these are the things that I want to see. So first up, if your README is long, please split it up. Give me a table of contents so that I can jump to what I want to see. There are generators online. If you don't know how to make a table of contents in Markdown, there are generators that will read your Markdown and make tables of contents for you. There's also a VS Code extension that will do this for you. Start the README with a brief introduction to your project. Describe its purpose, its goals, and its key features. Like, let me know why I care about this. What do I need to run it? What version of Node do I need, for example? How do I build it? And how do I run it? Give me some nice npm or yarn commands that I can just stick in the terminal and get going. Hold my hand as much as possible. Give me a usage guide, give me instructions on how I should be using your project, explain its functionalities, explain how I should interact with it, include code samples, include usage scenarios, and let me know whether there's any configuration that is needed, and give me details on how I can configure and customize the project. Give me actual examples of any configuration codes or variables that I need in order to get going. And let me know whether there are any constraints. Don't leave me to find them myself. So if there are any gotchas or design decisions that need to be called out, let me know in the README. Don't leave me guessing about whether or not it's my mistake or some decision that you made. And then there are other things that you can add to your README as well, or you can put them as separate Markdown files. So guidelines for contribution to your project, explain how I can run tests, how I can submit bug reports, how do I propose enhancements to your project, specify any required coding styles or linting rules, testing frameworks, anything that I need to follow in order to contribute to your project. Provide me with contact details so that I can talk to your team, be it an email or a Discord or a Slack or something like that, and encourage me to get involved, encourage me to reach out with questions, encourage me to give you a bug report. Make sure to include a code of conduct as well, explaining the behavior that you expect from your community and the behavior that you expect from any contributors, and how you will handle it if that behavior is not seen. If there's a code of conduct violation, what will you do about it? How are you going to make your community feel safe? And then, of course, clearly state the license under which your project is distributed, mention any restrictions or requirements, and whether or not I can modify your code if I'm using it. A well-written README really just improves the clarity, the usability, and the overall quality of how your project is perceived by your users. And this really is just vital for developer experience. But writing a README requires some level of technical writing, and good technical writing can make a huge difference to your README and to your other documentation, be it a blog post or a tutorial or something on a developer portal. And technical writing, again, is a whole talk in itself. It's breaking down complex concepts and making them accessible and digestible. And an important component of good technical writing is ensuring that you know who your audience is, like who's reading this writing. So you want to start the writing process by analyzing the audience and gaining a good understanding of who they are and why they're reading this document. Consider their level of technical expertise, their general cares, as in what are their roles and responsibilities, what is it that is important to them. Are they beginners? Are they intermediate users? Are they experts? And once you've identified who the audience is, then you can create a persona for them and assign this person a fictional sort of backstory, a fictional reason that they would be reading this document. And then when you're writing it, you can make sure that you're writing it with them in mind. Make sure that you are using simple, direct language to convey your message. Make it as clear and concise as possible. Keep a consistent tone of voice throughout your documentation so that the developer isn't surprised by anything. And write in low complexity sentences with low complexity vocabulary as well. So keep your paragraphs short and give frequent examples. I personally, if I'm greeted with a whole wall of text, I get like ADHD panic and my eyes just sort of slide across it like it's made of Teflon. So, break up your paragraphs with graphics, with some sort of illustration. Make sure that you're focusing on things like readability by using headings, making sure that you've got some sort of information hierarchy so that I don't get that panic of a giant wall of text. Make sure that you are writing descriptive titles in your links, which is really important for accessibility generally, and of course, put alt text on all of your images. Make sure that you're using inclusive language in your documentation. Think about removing ability-specific language if you can. So use read instead of see, and check out instead of look at. And don't refer to things as crazy or dumb. Instead, try wild or baffling. There's no need for gendered language in your writing. You can use neutral pronouns, and you can swap out words like man hours or manning for work hours or staffing, that kind of thing. And avoid using idioms or slang in your writing, because these are really confusing to people who don't share the same first language as you. And then try and avoid saying that a process is simple or easy. This can make folks who are new to a subject feel quite belittled if they're not finding the process easy and you said, you can do it in these 5 simple steps, and they're like, but it's not actually that simple for me. You can do it in these 5 steps. Then we're not belittling anybody. As I mentioned, I have an incredibly short attention span. If I get a big chunk of text, I'm scrolling my phone. I've opened Slack. I'm gone. So break up walls of text with illustrations, with graphics. It also helps people who don't connect particularly with written words. So some people are visual learners. So if you can give me diagrams, that will help accommodate people who learn in that way. And finally, consider different learning styles, as I mentioned earlier. So some of us like to read, some of us like to watch video. Some of us like to have a step-by-step tutorial. Some of us like to have a fully functional demo that we can just dive into and explore the code. Offer information in different formats. And the final thing that I want to talk about today is the code itself. And these are just a few things that I think that can make a real difference to your developer experience, because we spend the majority of our time with code reading it rather than writing it. And I'm sure we've all seen a lot of code bases where we just looked at it and gone, I cannot work out what this developer was thinking when they wrote this. We're writing code that other people are going to be reading, and it's important that we code clearly and with intention, because you're not going to be able to get a chance to actually speak to the developer that's using your code. They're not going to know what was in your head, so you need to make it obvious through the code that you're writing. Your code should be unsurprising, it should lower the cognitive load as much as possible, and it should be allowing them to stay in flow state as they work through it. So, how do we write clear code? Firstly, functions without side effects that do one thing and one thing only. They are easier to read, they are solely dependent on themselves, and they don't affect external states, which means that readers need to maintain less information in their head as they are reading through your code. Functions with fewer arguments, again, generally easier to comprehend. It's all about making sure that the developer has to keep less information in their head as they're reading through your code. If you can, refactor your functions to make them smaller and to reduce the number of arguments. Use promises. They are much more readable and intuitive than callbacks. They make it much easier to see the linear flow of the logic through your code, and they give you more concise code blocks than callbacks. They will help developers to understand the flow of the asynchronous operations in your code, and this will, of course, reduce cognitive load. Return early and often, so placing return statements at the beginning of your functions, you immediately communicate the conditions under which the function should exit. And again, it reduces the need for the developer to keep information in their head. Once they've gone through the code flow and they've gone, okay, we're returning when this thing is happening, they don't even need to read the next bit if they are working out the logic of that first part. It minimizes the need for the developers to hold multiple different conditional branches in their mind simultaneously. Avoid what we call the pyramid of shame, so lots and lots of nested if statements. As your nesting level increases, the code just becomes more convoluted, more difficult to read, less simple to follow the logic of. It's more difficult to understand the intention and what the outcome is going to be. The pyramid of shame can also lead to bugs and maintenance issues because it's difficult for you as a programmer to maintain the logic of what is going on. So pyramid of shame leads to increased cognitive load. As much as possible, use descriptive language and naming rather than abbreviations. Longer function names make it more obvious what the function is doing, and they make your code self-commenting. The goal of writing clear code is when you read it, you can understand what the code is doing. You may be tempted to write comments, but comments, as David Whitney says, are either lies now or they are lies in the future. And I understand sometimes you've had to commit some sort of cardinal sin in your code and you need to put a comment in there to tell the story of why that happened. And yes, okay, I'm not saying never write any comments, but comments should tell you why the code is doing what it does rather than telling you what the code is doing. That's what your naming should be for. And I'm going to make a lot of Vim users very angry right now, but I love long lines of code. Long lines of code are what we can use to make our code bases more readable. And, you know, I could see you all frowning at me in 80-character linting. So let's have a look at an example. You may not be able to see the code here, but what I want you to really concentrate on is the shape. So this is from an SDK that I wrote recently for the Spotify Web API. And it's an endpoint that returns artist data. And I think this is nicely written code, depending, if we take a look at the tips that I just said on the previous slide. So we have some nicely named functions. The functions only do one thing. There is one comment in here which is explaining an anomaly that the developer might see. And yes, I don't know if you can see it there, the albums function in the middle. It does have a lot of parameters. Unfortunately, it has a lot of different options. But what we've done here, we've put all those parameters onto one line. So as far as the developer is concerned visually, it's kind of something that they don't really need to head compute. You can sort of jump past it. You go, oh, there's a bunch of options there. What is actually happening in this function? I will sort through these options if and when I need them. Vertical space means something. It gives an importance to the information that's on the new line. It's kind of like, when you finish a paragraph, it's kind of like saying this is the end of this thing and this is the start of something new. It lends importance and significance and suggests a new sort of section of your code. And our brains will understand that if there's something new here, there's something new that I need to work out, there's a new piece of information that I need to store, and we're just adding more things into that cognitive load. So this is my beautiful bit of code. Let's see what happens when I run it through a linter that is set to an 80-character line length. So I don't know about you, but looking at these two blocks of code, I look at the first one and I go, okay, I can probably grok what is going on here. I can read through this. I look at the second one and my brain immediately goes, panic, there's a lot of stuff in here. We are lending significance to a whole load of lines of code that aren't necessary for the developer to comprehend on an initial read-through. To me, it's kind of like, imagine like you're midway through writing a sentence and you just randomly hit return and you're like, new line. So let's have a look at this. So starting right at the top, suddenly, for some reason, I need to know about all of these things that are imported. Before I've even looked at the rest of the code, just to satisfy JavaScript's module system. Like, I don't need to know about any of these imports. They're getting imported, cool. Why are we giving them 7 lines of importance right at the top of our code block? In the original formatting, it's only 5 lines later that you actually find out, when you might want to use, for example, artist. Whereas now that information is shoved all the way, like much, much, much further down the page. We've given the developer a huge amount of cognitive load before they've even started reading the file. Not only that, but we've actually removed some white space. So underneath my class definition, on the left-hand side, so you can see the class definition there on the 3rd line, I put a new line. I felt like this was helpful to delineate the difference between the functions that we're declaring and the class itself. These are separate concepts, but my linter has gone, no, shove all of that together. So now we've got a big block of code which starts to trigger my, oh my God, there's a huge block of text panic, and it's turned into Teflon, and my eyes can't read it. So the next block of code has been left unadulterated, which is nice, but that lack of space it feels smushed together. It feels like it's making comprehension more difficult. Now let's get to the really offensive stuff. So all of the optional parameters that I mentioned on that albums function there, that are all in one line, they've all been moved into a line of their own. And like potentially that long line, if you've got a really small screen, it might cause you to need a horizontal scroll, but it doesn't matter because I don't need you to read all of those. But now I am forced to read them all. I'm forced into head computing each line as I read it, rather than an instant understanding that this is a function. And to add insult to injury, if we have a look right down at the bottom, we've got a top tracks function. And this has been spread over 3 lines so that we could waste an entire line on a parenthesis and a semicolon, which honestly, to me, makes more sense to be at the end of the line that it belongs to, rather than floating on its own new line. And our related artists function here, so right down at the bottom, has managed to survive the tyranny of the linter unscathed, so at least we can be thankful for that. But don't worry, with all of this extra cognitive load, we have saved ourselves 3 kilobytes, so I'm sure the developer will be very pleased with that. And I'm sorry, Vim users, and I'm sorry, people who use ESLint. I just don't think that this is better. It isn't 1996. We all have widescreen monitors these days. We all need to be considering the legibility of the code that we're writing and the reason why we're writing it. If I am writing this for an open source project, which who knows which developer out in the world is going to read, I want them to be able to read it easily and understand what I was meaning when I was writing this code. So I guess what I'm trying to say is, my name is Joe Franchetti, and I love long lines. Thank you so much for listening.